The galaxies, cloud formations, your nervous system, mountain ranges, and coastlines all have in common. They all contain never-ending patterns known as fractals. A classic example of a fractal in nature is broccoli, in that the whole stalk is a similar version of one of its branches. So cut off one piece and you're left with a smaller version of the entire broccoli. Snowflakes are another example. It's often said that no two snowflakes are ever the same. And fractals offer a fascinating explanation as to why nature works in this way. Why nature continuously creates new, self-replicating, yet unique structures, and how the smallest things in existence are necessary components of the greater whole. The term fractal was coined by Benoit Mandelbrot, who was working at computer giant IBM in 1980. Mandelbrot had been fascinated by discoveries of mathematicians from the early 19th century who were attempting to define their understanding of what a curve is. Experiments such as George Cantor's discovery that a single line could be divided forever, and Helga von Koch's triangle, a shape that has an infinite perimeter but finite area, resulted in the term monsters. Mandelbrot used the modern computing powers developed by IBM to run these monster equations millions of times over. This process led him to a breakthrough equation combining the patterns found in previous monsters, resulting in his own set of numbers. This would become known as the Mandelbrot set, an infinite geometrical visualization of a fractal. One of the most amazing things about the Mandelbrot set is that theoretically, if left by itself, would continue to create infinitely new patterns from the original structure, proving that something could be magnified forever. Fractal geometry is currently applied in many fields, for example, research into climate change and the trajectory of dangerous meteorites, helping with cancer research by helping to identify the growth of mutated cells. It's even believed by some that the universe itself may be a fractal, and as you zoomed in, discover it made up of billions of galaxies. Inside of those galaxies you would find trillions of stars and billions of solar systems and planets. And on one of those planets you would find Earth. On Earth you would find continents, cities, and a human. And inside of that human you would find a brain made of millions of cells in which you would find trillions of synapses firing away. And inside of those you would find DNA. Inside DNA you would find atoms, electrons, protons, neutrons. Deeper still you would find quarks, neutrinos, and so on. And then, just maybe, continuously deeper into infinity. Some believe that due to their highly complex and mysterious nature, the greatest use of fractals is yet to be discovered.